Good morning, students. Welcome back to physics class. Before the class, I'm sure you have read the message given by our principal. It is very important to understand the very basic meaning or rather meanings behind the beautiful message written by your principal. Staying at home is not a punishment. Rather, it is an opportunity to explore your talents, to know about you, your own self, to make a stronger family bond, to learn as many skills as you can learn, to explore the most difficult part of our understanding, and to have a safe and sound mind, body and spirit. So hope you all are working. I am not sure about some 4-5 people who are not very regular in their response to my questions and homeworks. Make sure I have record of all children who are responding to my class, doing their work properly, and those who are not doing properly, do it. It is for your good, not for me, not for your parents, not for school. You are learning for yourself. One of the values which science teaches you is facing a problem and try to find out the solution of the problem. When you get all these numericals and problems in physics, it gives you confidence and courage that you can face problem and you can solve it. And if at all you cannot solve it, you can try for the solution. That is what our human life is all about. Well, with this note, read the message given by your principal again and again. It is quite meaningful. Every time you will read it, you will find out one more new value and one more new meaning in that. Now, back to our physics. We talked about acceleration, we talked about uniform acceleration, we talked about non-uniform acceleration, we talked about speed, we talked about velocity. All those things we talked about. The problem was, or rather, the problem comes. I am able to find out the speed and velocity and all those things, but it takes lot of time and it doesn't give me very quick picture. How can I get a very quick picture? That was a problem. You know, in olden days, when there were no computers, when there were not quick machines which can draw, people were struggling. A navigator, he has to sit down with his navigation chart and all those things, and then he has to draw this line, this angle, that angle, and then still he was not able to chart the easiest course for its journey. I'll give you one more example. Suppose one plane is moving like this and other plane is moving like this, and there is one ATC, air traffic controller, and both the planes have to come down to Delhi airport, land out. Now, how the plane 1 and plane 2 can be adjusted in such a way that they don't collide, they land properly, they maintain a safe distance? How can we do it? And it is that decision has to be taken within fraction of a second, because nowadays things are moving very fast. So if you don't have a clear picture of motion of a body at your immediate reference, then it will create a lot of problem. To solve this problem, people started to express or represent motion in terms of pictures and graphs. So today's class, we will talk about graphical representation of motion. How can we quickly represent motion of a body on a graph paper, and what inferences, what else, what more information we can get from that graph? Well, look at my presentation number 1. Here, observation is made. There you got distance, then you got time. One observer is there, he is observing distance, he is observing time and trying to put it in a table. What can you get out of it? Can you get any quick inference from that observation table? Think. Anyway, back. Now, the same information can be put in a pictorial form or on a graph paper to give us much more clear picture of the motion of a body. Remember your cricket matches? One team has made some score and there is one blue bomb. Other team has made or just crossed 20 over, 30 over. In the 50 over match, another 20 over is left. By looking at the worm at the graph, you can find out whether the team is scoring at the good rate or not scoring at a good rate, or whether what rate that team should score per over, what will be the run rate, so that they can reach the graph or they can win the match. So graph gives us pictorial information of the data, whatever data we collect. And that pictorial information helps us to find out so many other things hidden in that data. Anyway, for graphical representation, what you need? A simple graph paper. This is the graph paper which you look at. This is the graph paper. You got one horizontal line and one vertical line. Both the lines, when they meet, we call it origin. Now, if you look at it, it has 4 quadrants. 1 side, 2 side, 3 side, 4 side. Means it divides the paper in 4 parts. As you have already studied, from origin, if you move towards one direction, there is, say, positive. Just opposite to that direction you move, that is negative. Similarly, when you move on the top, it is positive, and below it is negative. Now, our business is not that 4 parts. Our business will be related to only 2 parts. That is x-axis and y-axis, both positive. We will not go in negative part of it because the quantities we will be dealing with are generally positive. Anyway, now I am going to plot that observation table on a graph paper. What I need to draw a graph, you need 2 things. Number 1, scale. Number 2, what are your variables? So, for drawing the table, we have taken 1 unit on x-axis as 2, how much? 2 seconds. And 1 unit on y-axis as 10 meter. Is it okay? Clear? Scale you got. Now second thing, variables. On x-axis we have taken time in second, and on y-axis we have taken distance in meter. Now back to your table. It is time 0, distance 0. Time 2 seconds, distance how much? 10 meter. Time 4 seconds, distance 20 meter. Time 8 seconds, distance 40 meter. Okay? This is the table. Now just check back on the graph and see, are we able to draw all these points and we got the graph? In 8th standard you have learned how to draw graph. So when the same data, same table is represented on the graph, you got a beautiful picture. You see one straight line. Now, the straight line which is O and A represents something. What that something is. Looking at this straight line OA, we can find out the motion of the body is uniform. Further, we can say the body is moving with uniform speed. And if you put up some direction into it, you can also call body is moving with uniform velocity. So, the same data which was in the table form was not very attractive and not giving any idea. Now the same data, when it is presented in the form of a picture or a graph, it is giving you better information. What information is that? Further, if you look at the section or just see the triangle ABC, the ratio AB upon BC is exactly what? Is exactly the AB represents the distance and BC represents the time interval. And what you call distance upon time? Speed. So, with this graph, we can find out the speed of the body. Very easily you can find out what will be the length of AB, you can find out, and what will be the length of BC. That will give you speed. In technical terms, we call that ratio AB upon BC as slope. So in one sentence we can say that the slope of distance time graph shows, of course, yes, shows speed. So if you have a graph and you are able to find out the slope of the graph, then you will be able to find out the speed of the body. This will help you to understand how you can compare. One plane is going to land at Delhi airport and its slope is, say, 5. Other plane which is going to land up, it has also slope 5. Then what will happen? One plane will land on other plane and be crashed. But one plane which got slope 5 and other plane which got slope 9 or 3 or 6 or even 5.5, both planes will not collide. So the air traffic controller ATC is sitting on the top of the airport. By looking at the graph, just distance time graph of the all planes coming to Delhi airport, he will be able to find out who is moving at what speed, whom to allow to land first, whom not to allow, all those things. So quick look at the graph only will tell the speed of each place. Anyway, in your practical life you can use it so many ways. Graphs have, especially speed time graph, they got beautiful meanings that you will study further. Back. Now see the graph on my computer, on my laptop. Now there are two graphs. One is zigzag, other is little curve, but both are distance time graph. Will you be able to say that both represent uniform speed or velocity? Of course, no. Since they are not the straight lines, you can say it is not they do not represent uniform velocity. Or find out slope at each section. All slope will be different to different velocity. So instead of finding and doing mathematical work and finding out which slope tells how much, you just look at the graph and say it is not uniform velocity. Work done, finished. Got it? Now, we got simple distance time graph showing uniform speed or velocity. Remember the difference between speed and velocity? Add direction to speed, it becomes velocity. So as long as we don't talk about direction, it remains speed. Only magnitude. Now, we can draw distance time graph. Can we draw any other graph? Yes. Suppose a body is moving with particular velocity and you are watching that and making a table, observation table, and find out. So you can also draw a graph that is velocity time graph. In velocity time graph, on y-axis we take velocity and on x-axis we take time. If the velocity time graph of a body is a straight line, what does it mean? It means, think. It means the body is moving with uniform acceleration. Why body is moving with uniform acceleration? Because if we look at the slope of the graph, that is the ratio there. What is that? What is the slope? AB upon BC. What is that distance AB? If you look at that, it is V minus U, is it? Yes. And what is that distance BC? It is T2 minus T1. In fact, it is the time interval, so you can call it T. So actually what AB upon BC gives you? Change in velocity upon time. And what is change in velocity upon time called? It is called acceleration. Got it? So another graph, that is velocity time graph. Slope of the velocity time graph gives you acceleration. Now, if slope is a straight line, or if the graph is a straight line, then the body is moving with uniform acceleration. And if it is not, simple, non-uniform acceleration. One more thing. Second part of it, just see, I have shaded it. The area enclosed in the velocity time graph represents the total distance traveled by the body. So, you got two information from velocity time graph. Number one, the slope of velocity time graph gives you acceleration or uniform acceleration if it is a straight line, and the area enclosed in velocity time graph gives you the total distance traveled by the body in that interval. Well, what is the fayda out of it? Why should we learn that? We should learn it because in our day-to-day life, I gave you example of one ATC wala. In day-to-day life, you can use it. Now, look at two graphs here and tell me what do they represent. Anyone? Now, broadly speaking, both of them are showing velocity time graph. But in one graph, the velocity is parallel to x-axis. What does it mean? The body is moving, yes or no? Yes, it is moving. But is it showing any acceleration? No. Why no? Because as the time is increasing or changing, velocity remains same. Right? So, here we get velocity time graph in which we have velocity parallel to x-axis shows the body is moving with uniform velocity or constant velocity. Now look at the another one. You know, when time is 0, velocity is maximum. But as the time passes, velocity is decreasing, and at the final time, by the final time, the velocity becomes 0. It shows what? It shows the velocity of the body is decreasing constantly or uniformly. So that graph shows you uniform retardation. Well, in today's class, I have tried to explain you the graphical methods for representing physical quantities, velocity, acceleration, and all that. You are going to get some questions, and make sure that you do the homework properly. If you don't know, don't worry, but do it, and make sure that you use proper graph paper when you are doing the graphical representation. I have done with a plain paper? No, that will not do. So you will use proper graph paper, and the questions which you have to draw, you will draw it on the graph paper itself. Thank you very much for your patient listening, and thanks a lot to all my students who immediately write back their comments or quickly do their homework and send it to me. Those who are little behind, come on, you can do it. Only thing is that you have to decide when and how. All the records of your homeworks, assignment which I send is there with me, and those who are sending, their names are also with me. Thank you very much. God bless you. Stay home, stay safe,